Hello, my name is Fatih Furkan Erkeç, and I'm going to do programming exercise 1, linear regression. In here, the exercise wants us to insert this code in here for creating 5 to 5 identity matrix by filling the following code, and we use NumPy library for this. We write NumPy i5, and when we run it runs correctly, and linear regression with one variable. In here we have a file. It contains the dataset for our linear regression problem. The first column is the population for city 10,000, and the second column is the profit of a food truck in that city in $10,000, and negative value for profit indicates a loss. We provide with the code needed to load this data. The data set is loaded from the data file into variables x and y. Plotting the data is often useful to understand the data by visualizing it. For this data set, you can use a scatter plot to visualize the data. Okay. We'll use matplotlib library for our plotting, and there is an info. We have imported pyplots module at the beginning of this exercise using commands from matplotlib import pyplots. It's rather uncommon. We usually see import matplotlib pyplot as plt. And in the following parts, our first job is complete the plot data function below. Modify the function and fill the following code. The code wants us to fill these lines in their pyplots plot x, y, and not this one, yes, row, comma, has 10, make k, py, plot, label, y label, profits in 10,000, and pyplots dot x label population of city in thousands. Okay. Now run the defined function with loaded data to visualize the data. The end result should look like the following figure. Okay, let's run. X is not defined. Let me check this real quick. I will stop the video in here. Okay, I fixed the error. It was about that letter, I think. Or maybe we didn't run this cell, but it runs well right now. In here we have gradient descent and the mathematical functions for doing that. And in implementation we have already set up the data for linear regression. The following cell we add another dimension to our data to accommodate, and we will execute one time. Computing the cost. Okay, as you perform gradient descent learn, minimize the cost function j. I will check this part in here. I will stop recording. Okay, we will do implement this function in here. Our job is doing this. We will make h value first, and h is equal to pi dots uppercase to x theta, and then we implement the j function. J is equal to 1/2m times m but we'll do it like that, and multiply that by 1 pi sum parenthesis 1 pi square and more square h sum y and one more square. Let me check the squares. This one is, yeah, let's do it like that, and okay, and return j. Yeah, it works fine. Here gradient descent, we will complete a function which implements gradient descent. The loop structure has been written for you. Okay, I will read this part and continue the video. Okay, now we will implement gradient descent. and we will define h, which is numpy dot x theta. Then we will theta equals to theta minus alpha over m times mp dots h minus y and x. Let's try that. After you finish the call, implement gradient descent function and print the computed data. We will initialize the data parameters to 0 and the learning rate alpha to 0.01. Execute the following cell to check your code. Let's check it. It has an error. Let's check that. Here's the error. I will check for it and I will come back. Okay, I think we made a parenthesis error in here because let me do it like that and close the parenthesis. Let's run it one more time and it works correct. We will use your final parameters to plot the linear fits. The result should look like the following figure. Okay, when we run it, it works just fine, same as the figure, and your final values for theta will also be used to make predictions on profits in areas of 35,000 people and 7,000 people. Note the way that following lines use matrix multiplication rather than explicit in summation or looping to calculate the predictions. This is an example of code vectorization in NumPy. Note that the first argument of the NumPy function dot is a Python list. NumPy can intentionally convert valid Python list NumPy arrays explicitly provided as arguments to NumPy functions. Okay, that's perfectly fine. And okay, it just works fine. In here, linear regression with multiple variables. In this part, you will implement linear regression with multiple variables to predict the prices of houses. Suppose you are selling the house and you want to. Okay. We will complete the feature normalize function in here and subtract the mean value of each feature from the dataset after subtracting the mean. Additionally, scale the feature values by their respective standards deviations. Okay, let me check the functions, and after that I will continue the video. Okay, we will implement move equal to numpy mean x axis equals to 0, and then we will implement sigma. Sigma is equal to numpy steady x axis equals 0, and after that we will implement x form x norm equals to x minus mu, and then divided by sigma. After that it works correctly, and after the feature normalize function is tested, now we add the intercept term to x norm. Okay, let's run this. Gradient descent. Previously you implement gradient descent on a univariate regression problem. The only difference is now that there is one more feature in matrix X, the hypothesis function, and the batch gradient descent update rule remain unchanged. You should complete the codes for the functions compute cost multi and gradient descent multi to implement the cost function and gradient descent for linear regression with the multiple variables. If your code in the previous part single variable already supports multiple variables, you can use it here too. Make sure your code supports any number of features is well vectorized. You can use shape property of numpy arrays to find out how many features are present in the dataset. The multivariate case, the cost function can also be written in the following vectorized form. Okay. You implement this function and j equals to 1 over 2 multiplied by n and multiplied by numpy sum numpy square numpy dots x and theta minus y. Let's run it. Oh, here we have for loop. We'll implement the theta in here. Theta equals theta minus alpha actually let me check this part first. Okay, we divide alpha by m. Let's do it parentheses, then multiply that by dot function np dots x theta and subtract a, and that's then dot function of that's x. Okay, let's run that. Here your graph looks very different, especially if your value of j increase and blows up. You can't train values looks clear. Okay, first let's start the code. After that we will check that, and it works fine. As you can see, it decreases about 10 or 15. Then yeah, it's the same. And in here, normal equations. In the lecture videos, you learned that the closed form solution to linear regression is that function. Using this formula does not require any feature scaling, and you will get exact solution in one calculation. There is no loop until convergence, like gradient descent. First, we will reload the data and ensure the variables have not been modified. Remember that while you do not need to scale your features, we still need to add column 1 to X matrix to have an intercept term theta 0. The codes in the next cell will add the column of 1s to X for you. Okay, let's run this code. Complete the code for function normal eqn below to use the formula above the calculate. We will implement this formula in here, and let me check how can we do that. easily. I will check it and continue the video. Okay, let's implement the function. We define transpose for this transpose formula and np dots dot function of transpose x and x, and then define theta if theta equal to np dots 1 pi 1 lg inverted transpose, and then np transposer x and that function y. Okay, that should do that. Couldn't see the out. Yeah, you could see that was the output, and it was finished. Thank you for watching. Have a nice week.